Okay. Okay. Guys, we are live now.
Awesome. So, friends, the YouTube channel. Hello, everyone. Cool. So let me give you a quick introduction of our speakers that are present with us here. Sri Rajan, you can say hi, and Shivatsa, you can also say hi to greet all of our members here. So we'll just begin in a minute. Hope all of you are having a good day. It's a nice warm Saturday here. So I'm out here in a small town called Vellore in Tamil Nadu, and I think Sri is with us from Kerala, and I think Shivatsa is the only lucky one back in Bangalore, and Dibyo is talking from West Bengal, from his hometown. So we're here from all over the place, and so the chat is right there below in the YouTube. So you can go ahead and start networking. You can talk to each other. You can tell us where you're from, what you do, and so we can begin a small conversation. Until then, I'll just introduce the people here. Me, I am Ananya. I am representing GDG Bangalore and Women Techmakers Bangalore for the, I think, past couple of years. And Dibyo here with me is also one of our members, long-time members of GDG Bangalore. He's also an organizer. And Dibyo, you can also say hi.
Hey, hi guys.
Awesome. So yeah, you can talk to us. You can catch up with us on Twitter if you feel like talking about anything or maybe sharing something with the community. Hit us up. And our speakers here, like I mentioned before, Sri Rajan, he's a lead engineer at Rapido Labs, and Mr. Srivatsa Katta is the head of engineering at the same place. So some cool things about them. Mr. Srivatsa Katta loves painting, apparently, just like me. So I think you can hit them up with requests of doing some nice landscapes, seascapes. I don't know what he's into, but probably something fun like that. And Sri, I think, has been having a hard time in lockdown because he loves playing football and he might have not been able to pretty easily do that recently. But because he's in Kerala and Kerala is awesome, so I think he has resumed his fun activities. You can also talk to them on Twitter, and I've mentioned their Twitter channels below, so you can catch up with them there. You can also follow them on LinkedIn that I've mentioned as of now, and probably connect with them while we wait for more people to join in. I think there are around 27 people watching, and we could start. So just to give you a little overview about what's going to happen today, it's more than a tech spec talk. It's going to be more of an architectural and seeing the whole thing in with a big eye, with a wider view, and architecturing and design thinking of the whole process. So an interesting thing of why this talk today is named Courage and Madness. Well, I'm not going to tell you. Those two are going to tell you in a few minutes after they go through a few slides, probably. And so they're going to basically talk about all the challenges they faced and why they wanted to get to, and how they wanted to get to where they wanted to get to, and how they did that, and their mistakes, and probably what you should or should not do when you are going through those stages in your product cycle. So I'm also going to let you know the medium that they have, you can go ahead and give them a follow there also. So they have really intuitive content there. It's also over to you,
Sri?
Yeah.
Cool. I'm presenting now. Can you see my screen?
Yep.
Okay, go for it.
All right. Good evening, everyone. Thanks, Ananya and Dibyo, for giving us this opportunity at GDG to talk about some of our learnings. And thanks for the great introduction. Yeah, just a word of caution. I'm just an amateur painter. I think like the topic says, Ananya briefly touched upon what we would like to cover over the next half an hour or 1 hour or so, is about our journey of the massive digital transformation. A very, very small team did at Rapido. If you have any questions, some of our team folks are also on the chat. Feel free to keep using the chat to ask any of those questions, and we'll try and answer as we go, or if time doesn't permit, maybe towards the end of it, right? Next slide, please. Quickly about Rapido. How many of you, I'm not sure how many of you use Rapido, but Rapido is one of the largest bike taxi in India, at least, before the lockdown and the COVID hit us. And we do believe it's still the largest bike taxi platform in India. We're close to about 100 cities. We introduced in 2015. It's been about 4 or 5 amazing years and quite challenging, quite interesting. We do have about 15 lakh and more registered captains on our platform, and you learn more about what we do and over the next set of slides. Briefly, if you've not used Rapido, please do use. It's the most affordable and the safest transportation available right now. And we are all over tier 1, tier 2, and even in quite a few tier 3 cities across India. Sure. So what we want to cover is, this is a picture of a year back when we started our journey, where we were. I think, like I said, the team was quite small. We were probably about 15 to 20 developers, all across different roles, including DevOps, including mobile development, including application development, backend support, everything. And over the last 5 years, like every other startup journey, there was obviously, the resources constraint. So obviously the skill sets would be very, you wouldn't find diverse skill set and whatnot. So the journey started and the systems evolved. And within no time, Rapido reached like 80 plus microservices, which are deployed across 200 plus systems. And given the pace at which we had to run to establish ourselves in the market, we had to rush a lot, and there's a lot of tech debt which got accumulated as well. Nevertheless, we never shied away from giving the promise of affordable and comfortable mobility, last mile mobility. And I think to make sure we live up to that promise, the team did a lot of hard work, try to hustle things up, and got to the state where we were at a year back in terms of quite complex systems. Some of it is probably not warranted, but it's just how it evolved, given the number of people we had, the amount of time we had, the amount of resources we had. And as you could see, given we were running with quite restrictive resources, we had to pick all the cloud providers, whichever gives us the best cost effective solutions at that point in time. And even before we realized, we were on 3 different cloud providers. Like we were on DigitalOcean, we were on Google Cloud, we were on AWS. Even the technology stack, I think the choices were made purely based on amongst the given set of people we had, what do we know best? because we believe technology is just a means to get to an outcome. So it was more about pick the right technology to solve the problem in a quick time. So we took calls in terms of what are we good at. Let's work on our strengths and try and solve the problem. Instead of maybe I think that's probably pretty much every startup story around. Instead of trying to pick up the most exciting technology out there at the beginning, losing your focus on the problem instead focusing on technology. Like every startup, we also started with let's focus on the problem. Technology is something which you could evolve, which you could change. Of course, it comes with some bit of cost. And that's what we're going to be talking about the next bunch of slides in terms of how we evolved our technology, how did we went through our transformation, so on and so forth. Even a year back, when we had to start this transformation, the kind of traffic, as you see on the last picture, is about 50,000 RPS, right? That's not any a small number to deal with. And our business runs 24/7. However, the traffic patterns are a little different at different hours of the day. It is, quite heavy traffic on our system. So everything that we speak about, that plays a key role. In terms of during digital transformation, where if you have to support your business 24/7 without any business disruptions, what are the different strategies and the paths that you have to take, and what do you need to keep in mind? I think those are some of the things that you'll probably hear from us over the next few slides. Next slide, please. Yeah, so I think you saw the picture of where we were 1 year back, right? And I'm sure some of you would be wondering, how did you have to deal with that? How did we have to deal with this? We did had a lot of challenges. I think there's no shying away from that. We had within no time we had 80 plus microservices, and a lot of these, and there was a lack of automation, which means that because many of these things are manually deployed and manually managed, every time you have to change either an application or a configuration, there was a drift created in the system. Some of them were not driven through source code because, again, hustle up with a very small set of resources that we had, make some config change directly on a machine. There were a lot of, unhygiene practices. Not so we intentionally wanted to do it because that's the best we could do given our resources and the time that we had at that point in time, right? Again, the way we used to scale were mostly reactive, which probably wasn't good enough. The deployment and release cycles were a little longer, which, if you have to, and we were, as Rapido last year, we established a market fit. We've expanded across the board, and we were at the path and the journey of hypergrowth. How do we double down, triple down in a matter of 6 months what we've probably built in the last 4 years, right? And there wasn't a consistent way of monitoring our systems as we scale, and onboarding new developers and new services who join our company, or when we start a new set of solving business problems, when we come up with new technologies, it wasn't easy to onboard. I think these are many different challenges that we had at that point in time, and which started us thinking in terms of we have to take this head on. It was a lot of madness, and it took a lot of courage for us to go through this path, even envisioning the journey and envisioning the path, and getting the confidence of the business, getting the confidence of the leadership, saying, "Hey, we are small, but trust us. We know what we're doing, and trust us, and we'll take you through the journey, and it'll yield the results that we are looking at." And that's how we started this journey, and hence the title of the topic as well. And when we started with the journey, where we wanted to get to, next slide. Here's where we wanted to get to, right? We wanted to converge all our cloud providers or consolidate into one single cloud provider, obviously for unknown reasons in terms of, the latency when different systems are across different cloud providers would not be as efficient as you want it to be. The maintenance not going to be easy. The skill sets is not going to be easy, the kind of skills and the the experience that you need to manage in one cloud would be very different from another cloud. Though there are technologies which are cloud agnostic, there's still that niche 20-30% which is explicitly required to manage at scale, requires very cloud specific knowledge and experience, and having a team who knows every single cloud provider and tips and tricks wouldn't have been an easy thing for us to manage. And I think the cost also played a bit of role, and the ease of use and the kind of skill sets that we had. I think the biggest challenge we took on was how do we converge it into single cloud provider. I'm sure some of you, I don't know how many of you are working with enterprises, startups, and all of it. Typically, something like this for such a complex system in enterprise companies and big companies, it's a massive bet, right? And and this kind of transformation goes on for years and not months. And we signed up for a target where we would like to get it done in a span of 3 to 6 months, and you'll hear how we got there. I think that was the kind of scale that we're talking about, and the kind of pace at which we attack this problem is why we said took a lot of courage in that madness, right? The single cloud provider was the biggest driving factor, and having repeatable and consistent deployments, because as the business was growing, the team was growing as well. The need for adding more and more features into the product and the system, even expanding our business into other verticals, apart from bike taxi, we've started, we've recently introduced a courier, like a person-to-person courier thing, because we had the ecosystem around in order to do that. We've also started expanding it to small and medium enterprises in order to deliver whatever customer needs at their doorstep, right? So given we had built a platform in the last 4 or 5 years, it was time for us to start looking at how could we leverage that platform into different business models as well. Not completely tangential to what we do. We still focus on mobility. We still focus on last mile logistics. We always had delivery, but we started expanding aggressively, especially during the COVID time, because that was the need of the hour. And how do we get to single click deployments? How do you secure our infra? Security is something that most startups do tend to oversee initially, because their focus is get the market fit. Focus is on the pace. Security always takes a backseat. But if you're in a B2C space, irrespective of what space, I think security needs to be thought through, and security first as a principle is something that as technologists we should be passionate about. I think that is something we wanted to address as we went through that digital transformation. Some of the simple principles we put on paper is no SSH access to whomsoever it is, right? Except for maybe a small set of people who are managing the infra. None of the developers needs to have SSH access, and no machine would have public IP except for very small attack surface. Attack surface were really huge when we started our journey. Pretty much a lot of machines had public IPs, because one of the reasons why we had public IPs was also because it was in multiple cloud providers, and having public IPs. Of course, we had secured them. There's authentication and authorization in place across both the ends. It still required us to interact between multiple cloud providers. So the exposure of public access was too risky for us to not focus on that. And as we grew 80 microservices, there wasn't an easy way to control business toggles. For example, if business wants to give turn on this feature in a particular city or turn off this feature in another city, not having a centralized configuration wasn't a thing that we could afford, or rather it was becoming a lot more challenge. So we wanted to get to a place where we gave simple tools both for the business as well as the developers to quickly turn on, turn off something, which meant centralized configuration. And how did we get there? And observability, whether it is monitoring or logging, how do we give seamless visibility into such a complex system which is running and supporting the scale at which we were going at, right? And unless we focus on some of these things, there is no way that we could stick to our principles of no SSH, no access to machines, and so on and so forth. And how do we move from reactive to addressing the scale concerns into a proactive? How do we get to a point where people don't even have to keep staring at their monitoring, and people don't have to sit in front of their laptops to support the system? How do we get into auto healing and auto scaling kind of an infrastructure? And I think the major important thing also as we grow, how do we simplify onboarding of new people into the company? And one of the challenge we took on was, when a new developer joins a company, how quickly can they add value to the business? In another way, I think what we ask them is like, look, you have all the tools, all the automation in place where you should be able to write a first piece of code and push it to the production and start feeling the impact that you've made to the business on day one. And it's not like weeks or months, it's day one. We expect people to do that. And we continuously strive towards to help them in, smoothing their onboarding and all of it. The same is true for when we have to start with any new, ours is a microservices architecture predominantly. And there's obviously, as and when we launch new capabilities into the system, how do we make that process easier without having to compromise all the architecture principles that we have put in place, and to keep it consistent. So we had to automate even onboarding of new services or onboarding of new capabilities, if I were to put it that way, easier. So these are some of the goals that we have set ourselves, and that's how our transformation started, right? I think it's a great learning for us. It was a challenging journey, and we'll talk about how we got there. How we went about preparing for it. Next slide, please. How we went about preparing for that, and why some of that preparation is really essential over the next few slides. Over to you, Shri.
Cool. Thank you. Can you confirm that I'm audible? Hello, Kata.
You are.
Yeah. Okay. Cool. Yeah. So, like as Kata mentioned in the previous slide, we kind of had a target. The target was very clear at what all goals we wanted to achieve. That was laid out very clearly. We did spend a lot of time to understand what we wanted to achieve, what are the current hiccups in the system, and what is the target state that we wanted to achieve. Although we knew the target state, what was not very clear was how do we achieve that target state? Right? What are the different things that we need to attack, and how should we design the solution to solve that problem to reach that target state? Maybe at that point in time, we couldn't consider it as fundamentals because some things really stood out, and we knew without fixing these things, there was no way of going forward. And that's what we have laid out here. So we'll go through each of them briefly now, and we'll go to a little more in depth over the next slides. We'll give you a brief on how it started, how has it evolved over a period of time, and what is the current state. In between, talk about what are the different challenges that we faced. So as mentioned, these four things we decided early on, like observability, automation, config management, network and security. We decided early on, these are certain things that we will not make any compromise on. Like without visibility into a component, we will never we will never attempt a migration on that component. So we need to understand whether it's healthy, what is the success rate, error rate, and all of those things. We have to have complete view on that system, without which we'll not make a migration attempt on that particular component, right? The other thing that we said will not make any compromise on is automation. There are multiple instances where automation helped us. We'll give you those details once we cover a few slides. But we decided any component that goes ahead and sits into this new infrastructure will have to be automated. Like be it the infrastructure itself, be it the network, be it the build and deployment, everything has to be automated. And we also believe that the automation everything should start from Git source control. So we try to strive hard towards putting everything to Git and starting the whole journey from Git, so that even if other systems go down, we always have our source code, so that we could drive everything back from source code, right? That was the second thing that we said we will not compromise on. Config management, like Atta mentioned, there were multiple challenges, so we had to attack it, without which deploying to the new infrastructure and deploying to a Kubernetes cluster would have been extremely hard. Network and security, yes, that's very important. I think I don't have to mention how important security is. And when it comes to perimeter security, how important it is to design your network the right way, so that you don't end up having accidental disruptions, as well as from an external attack perspective, you're kind of covered. Right? So we'll go in details on what we did for some of these things in detail.
Yeah. Just to add on to that, I think when we start with a digital transformation, I think there are multiple different ways every organization attacks. I think one approach is to have everything in place and get onto that journey, and the other approach is hey, just jump onto that journey and we'll figure out when we have to cross that bridge, right? So we took a pragmatic approach. We felt that there are some essentials which are absolutely required to give us the confidence during our migration and the transformation, and there are certain things we don't have to over engineer right now, even though that's probably the most ideal thing and the most recommended thing by the community, because maybe we don't need it, right? So we took a very pragmatic approach to get there. I just wanted to call it out. Go ahead, Sri.
Yeah, so let's talk about observability. So two aspects, monitoring and logging. Let's start talking a little bit more on monitoring. Like I mentioned earlier, it was very important for us to understand how well the component is doing after migration, without which we would not be in a position to take a call on whether we should go ahead with the migrated service or should we be rolling back, right? So it was very essential for us to get that visibility, complete visibility. I don't think any much of visibility will be lesser. So we wanted to have that. Now, of course, the tooling is quite standard. We use Prometheus and Grafana. Assuming most of you would have used Prometheus and Grafana in the projects you're working on. So Prometheus is a leading open source monitoring solution coming with multiple capabilities. You can store metrics, query the metrics. There's an alerting system as well. Grafana allows you to query and visualize the metrics, right? I think when we started, we also said, hey, we will deploy Prometheus and Grafana, and we deployed Prometheus and Grafana in our Kubernetes cluster. All good. It started giving us metrics on the metrics of our Kubernetes cluster, like how many deployments, is a deployment healthy or not, is a pod unhealthy or not. Everything was good. So far, so good. We were kind of, wow, this is nice. This is pretty cool, right? But then it was not that easy once we started adding more and more tool set into our ecosystem, right? So one example was we started using Istio. Istio is a service mesh built on top of Envoy proxy. When we started pulling in Istio into our tool set, Istio has a lot of metrics that gets exposed, and when we started scraping those metrics also from this particular Prometheus instance, we started facing problems like high memory utilization. It kept on crashing because of out of memory errors. We tried vertically scaling it, but that didn't help beyond the point because it was still asking for more memory, right? So that's when we realized, okay, this might not be the right way to do it. Maybe we need to do it in a better scalable fashion and more reliable fashion. We started thinking how we approached the solution was, we started categorizing the sources of metrics. Like there were different components which were exposing metrics. Istio was exposing metrics. There were another component which was exposing Kubernetes metrics. We had an API gateway which is also exposing metrics. So we started categorizing these metrics, the sources of metrics, into different categories. And what we did is we started having one Prometheus instance per category. So there is one Prometheus instance for scraping Kubernetes metrics, one for scraping Istio metrics, one for API gateway, one for metrics from VMs, which could be databases or any other data stores that we have. So this took us to a better state, predominantly because now the load is not on one Prometheus instance; it's kind of distributed, and many of those we didn't have to scale it up drastically. They were not using much of resources, so for those of them, we could run it on a small server. Whereas in things like Istio and API gateway, they were kind of heavy and intensive processing was happening there, which required a lot of memory. We were able to allocate different servers for them. This was a bit more. This was better than our earlier state, but we still had issues with this. This was our second stage. Some of the issues that we faced with this setup was. We really don't have a highly available solution. We do not have a high availability for this one, right? So if you look at that, there's only one instance of Prometheus running. So if there is a query that comes up, which kinds of looks for a larger period of data, there happens to be a high memory utilization, and there could be a downtime from that instance perspective. So availability was one problem with the setup. The other one was we couldn't support long-term storage. We tried 3 days, 4 days, 7 days, but the moment we had 7 days, and when we were querying for 7 days, that also spiked up memory. one of the issues with those was the query was also coming to the same instance, whereas the same instance was responsible for scraping also. So that was kind of doing a little bit too much, and we had occasional issues with that, with performance, with availability, and all. And it started becoming a pain point. And as I mentioned earlier, the visibility into the system was of utmost important to us, even before or after migration. So we started thinking about, okay, fine. What is the next best state that we can reach, right? So that is where we started spiking on Thanos. So Thanos gives you long-term storage with Prometheus, and it also comes with its own query. So once Thanos came into picture, all these Prometheus instances predominantly does only one job, which was scraping the metrics. The primary query interface was Thanos. We were also able to reduce the retention period of these individual instances to hours, max a day, and a larger duration of data was stored in Thanos, because Thanos allows you to store it on storage buckets like GCS or S3 or anything of your choice, right? So Thanos allowed us to store the metrics over a longer period of time without having much performance impact on the running Prometheus instances. We're still seeing small issues, but this is a much better state compared to where we were, and these are the different ways we evolve the system. And we're kind of confident with the current monitoring setup now. And with the long-term storage, it gives us a lot of analysis opportunities on how our traffic is building up, how is our CPU usage, should I be fine-tuning my resources for specific services, and so on. So the options that it gives with the long-term storage was also helped us to fine-tune our systems over a period of time. I think that's it from a monitoring perspective on how we evolved our monitoring stack. Let's move on to logging next. Kata?
Sure. Yeah, I think monitoring is not just enough because it tells you the state of the services. It doesn't tell you the inner workings of the application, right? If you want to start looking into how the application is performing across different scenarios, different data flows, different user interactions, and all, I think that's where logging comes into play. I think there was a question on how without SSH access, how do people do deployments? How do people look into things? I think some of this monitoring and logging are the ways through which you can provide whatever visibility you need of your systems where you don't have to really do that. We'll talk about deployments in a bit, but in terms of logging, again, we've used the standard ELK stack. ELK stands for Elasticsearch, Logstash, and Kibana. Elastic is an index search, free text search engine, which got evolved into the first prominent use case was to use it for logging. Now it does, pretty much wherever you have a use case of free text search, you could use Elastic. Kibana is, you could visualize it as a face for the Elastic, where if that's where you go and discover what's happening with an application. You could apply different filters, you could apply different groupings and understand in terms of, for this particular flow, what's happening, for this service, what's happening, in this environment, what's happening, so on and so forth. And FluentBit is more of a log shipper. So this sits closer to the edge nodes, which is purely your services or your VMs, where its only job is to to know where to read the logs from and ship it to Elastic, right? So this is a plain vanilla thing. Which worked to an extent, but as we started moving more and more services to leverage this logging infrastructure, we started facing challenges. Right, one of the challenges was there was a lot of load on the Elasticsearch instance, which the pace at which the logs were generated by the services. The Elasticsearch with a given set of nodes that we had wasn't able to index at the same pace. Obviously, one of the options could have been horizontally scale Elastic, but how long do you scale, right? There's no end for that. So we needed some way of throttling it. We also needed an ability to decouple these two things, where if we were to upgrade Elasticsearch, some of the major versions, it requires a full cluster restart. So how do we do full cluster restart without having to lose logs? Was another challenge we started facing, because as we do the transformation, we've also ensured that we are on the latest stable version of every single software that we are using. Hence, we couldn't have compromised on tight coupling across any of our systems that we had. While FluentBit or some of the file beats of Elastic Stack itself does support some kind of tolerance to, like, even if ingestion is not happening, it could throttle. The way it throttles is by making sure, at least you need to make sure the logs on your edge nodes, there is some kind of rotation, log rotation using log rotate, or application could do log rotate, or an OS level tools are there to do log rotation. Some of those file beats are compatible with that, but that requires you to have a huge disk size whenever that happens, and having a huge disk size to accommodate for a non-regular day where there may not be log rotation for, like, at GBs and terabytes on every single day. So it didn't make sense to have, like, allocate a huge disk size on the edge nodes. And that's where we evolved into the next stage, which is introducing Kafka and Logstash. And Kafka is a streaming solution, which is, I think, one of the best out there. I think it takes away the complexity from the publishers to the consumer side, purely because of its architecture. It's purely IO bound, and it has a great, it leverages the file system cache really well, and that makes it the best choice for any kind of streaming solution. What the kind of role it played over here was, it acted as an intermediary streaming or a storage, where the publisher doesn't have to worry about whether the ingestion is happening at the same pace or not. Just keep pushing as and when the services are spitting out logs. And Kafka used to keep it in its store, like in its broker, across different topics and partitions and whatnot. And Logstash played a role of transforming that. Like Shri mentioned, we weren't just monitoring just the services; we were also monitoring databases, middlewares, Redis instances, MongoDB instances, caching solutions like Memcache and whatnot. And every system spits out logs in a different format. Wherever we had control, we tried to move to standardized JSON logging. We're still in that journey. But things which are open source and where we can't control the kind of logging format, we had to do some kind of transformation so that at the end of it, when people have to explore from a Kibana, they have a consistent way to filter those logs. And Logstash was playing that kind of a transformation job, where depending on the source of the log and the format of the log, it used to transform the way we wanted to, and then used to ingest into the Elastic. And then Kibana is just a phase for it. And this got us to a state where we've decoupled ingestion with the log shipper, and we've allowed it to have, and we've come at a place where we could upgrade. We could horizontally scale. We don't have to worry about the pace of ingestion and log shipper, and we could even afford for Elasticsearch, going down briefly or temporarily, because Kafka would have, like, Kafka itself was set up in a replicated mode and all. While this worked, just a word of caution: just because there is a way to do it, I think if you were to take these choices, do it carefully, because it comes with a cost. Now, not only you have to maintain Elk Stack, you also need to maintain Kafka. And maintaining Kafka itself comes with its own challenges. And while we say Kafka, it's not just Kafka. It pairs up with zookeepers. Now you need to understand how to have clustered zookeeper, how to have clustered Kafka, how do we scale that horizontally, and all of it. So it definitely has a cost. But we were shipping logs at close to 2 to 3 million logs per minute, right? And that's a lot. And if you have that kind of a scale, and if you have that kind of massive injection rate, maybe something like this would be a solution or a design you should be looking forward to. Next slide, please.
Cool. So yeah, automation, I don't think we have to specify or mention explicitly its importance. So this was a journey we started. We knew the end state, but we were not very, very clear on how we would reach that end state, right? We had some idea. We did some preparations. We did have a lot of discussions within and whiteboarding to understand what are the different choices that we need to make. But we always knew that there would be scenarios wherein which we will have to make a course correction. Not like every choice will be the right. Like we saw in monitoring as well as in logging. We started with something and then we had to evolve because of the different requirements and everything. So we knew that, and that is the reason why we said, okay, automation should be of utmost importance. We should be automating anything and everything that is possible, right? And by doing that, we also ensured that if we are automating, so it has to be driven via code. So that gave us an option of reviewing the drift of the infrastructure as well, right? So like, for instance, we automated anything and everything that we create in GCP, starting from a GCP project to a VPC, to a subnet, to a firewall, to pairing and creation of a Kubernetes cluster, creation of virtual machines. Everything is automated via Terraform. Now that gave us an opportunity, like any new change to the infrastructure, it shows us a drift, like what is the diff that is going to get applied, and it also allowed us to brainstorm on different aspects, like how much is the cost increasing, for instance. Like if a new network rule is getting added, why should we do that network? Why should we be opening that particular port? So these kind of discussions also helped, and there was a constant review on the infrastructure on how it is changing. Right? So that automation kind of driving the automation via Git also helped us to get into a state where in which there is a constant review of infrastructure that is happening. Now, apart from infrastructure, yes, we had to automate deployments. Like any service should have a seamless deployment pipeline. The moment someone check into GitHub, it had to be built, packaged, and then published into some container registry, and then we had to deploy it from there. So we use GoCD as our CI/CD platform and Helm for deploying the application. Overall, it also helped, again, as I mentioned, it definitely helped us a lot when we're doing some changes in the design later after realizing, hey, this is not the right way to move forward. We'll give you a few examples over the slides. That's it about automation. Yeah, the text that we used is Terraform with Ansible for creating and provisioning infra, and GoCD and Helm for build and deployments. Let me go to the next slide. Yeah, config and secret management. This is an interesting one. Okay. So as mentioned earlier, like we had configurations spread across repositories and secrets also sometimes spread across repositories, right? And we knew from day one itself, without fixing this problem, there is no way we can move forward. This has to be attacked some way or the other. Choosing the technologies was easier. Okay, we had a plan in mind. Okay, so the plan was, okay, we will centralize the config. The config will go ahead and sit in console and vault. So console has a lot more other capabilities, but we are using the key value store in console as the config store, and we'll use vault for storing secrets. And once it is there, it kind of becomes the central store for configuration and secret. And any service which is getting deployed will start reading the configuration and secret from these two sources. Now, this plan was there. We also knew, hey, this is going to work well. But what we didn't have a clarity on is how do we populate the configurations to console and vault? Like, what is the source of truth for the configs and secrets? What if tomorrow, okay, fine, you can do like backups of console and vault. Vault uses console as a backend. So taking a backup of console would give you some kind of, failover mechanisms. But then what should that be the source of truth? And if someone has to add a new config, do they just go into the UI of console and then add it? We're not very comfortable with that aspect. Okay? Again, one thing that we have been, what we keep focusing on anything and everything that built is the drift. We are always interested in how is the drift happening? Do we have a visibility onto the drift? Like we mentioned in infrastructure, if a new component is getting added, we have a clear visibility on, hey, this new component is getting added. So we wanted to have that kind of a visibility and a reliable pipeline for pushing the configs and secrets to these sources. Then we fell back, said, we're going to start from GitHub. All our configs and secrets will be in GitHub. Now all we need to figure out is a mechanism to push it into console and vault. For that, we couldn't find anything. So what we went ahead and did is we wrote our own tool. So we chose Golang as the programming language. We created a tool which is capable of reading these configs, doing some validations, like are the configs in the right format, are the mandatory fields being filled up, and so and so. And once that is done, it kind of has an ability to show you the drift also. I'll show you an example in a while. It has an ability to show you the drift, what is getting changed, and then finally it goes ahead and apply. This helped us. So this helped us in multiple cases, right? Because configurations, once you move it to a central position, one of the things that you might miss out on is if you change one configuration, and if it's an erroneous change, it could potentially impact majority of your services depending on the configuration you're changing. So you have to be extremely careful on how these configs are getting updated, and it's better to take it through a thorough review process where people have the visibility on what is getting changed. Now GitHub did allow you to look at the diff from a commit perspective, but before the deployment, multiple commit might have been accumulated, and when we wanted to see a diff at that point in time, it was kind of becoming a little hard. So this tool allowed us to bring in all those capabilities, and the pipeline was kind of more reliable and resilient to failures, right? Because it was kind of doing all kind of necessary validations and giving enough visibility before we go ahead and deploy it. You might be wondering, like, if you're using Vault and if you're using storing the secrets on GitHub, what is the point? Because anyone could go into GitHub and see the secrets. You're right. We didn't store it in plain text, so we used a solution called as GitCrypt, and we had a separate GitCrypt key which we used to store in one of our other vaults, like one password, where only specific set of people will have access to, who needs to change this particular secret, right? So the secrets were not stored as plain text in the repo. It was encrypted and stored. So this is the view on the diff that we were talking about. So anytime someone checks in a configuration, the tool is capable of giving you that diff view, like, hey, you have modified this particular config. This is the current value on the server. This is the new value that has to be deployed. Are you good with it? If you're good with it, go ahead and deploy it. If you're not good with it, then yeah, maybe there's something that's going to go wrong. So this kind of allowed us to, like anyone could potentially go ahead and add or modify a config, and before deployment, all of them are confident what is going to be applied because there was clear visibility on what gets applied. So that increased the confidence, and this was one of the mechanisms that had to be widely adopted because every service will need to start using the system. So the number of deployments that goes into this repo was also huge. So that was a high churn area. So we suspected it could potentially cause problems, right? So that is why we went ahead with a solution which is driven via GitHub and kind of have the ability to show you the diff and do some basic validation before we go ahead and deploy it into the corresponding environment. There was one more thing which was challenging with the config or secret management solution is, if you're driving from GitHub, like many of the projects, I think once you get into GitHub, structuring your repository is very, very important. Without which it's most probably going to be unreadable and most probably unmaintainable. So we also had to do a lot of back and forth with structuring the config and secret management. So the branch per environment, the left picture showed on how we started off. So we were thinking we will have one branch per environment. So let's say we have 3 environments: development, staging, and production. We will have a development branch, we will have a staging branch, and we'll have a production branch. But this started to become very unmaintainable and very confusing over a period of time. Right? Because once you have branches, the normal thought process in Git would be, okay, I've checked into one, let me merge into the next branch, and then let me merge into the next branch. So it's kind of going up the environments. But then configs doesn't work like that, right? Because configs are completely, the values of the configs are completely different across environments. Of course, the keys are the same, but the values are completely different. So it was becoming confusing because people would check into development branch, but they might forget to check into staging branch. And then there was a lot of messes happening here and there. We revisited the thought, and then we eventually moved out into a state where we have one branch, one master branch, and we have one folder per environment. So if you look at this image, there are three environments: dev, production, and QA, and the config, secrets, and everything is checked into that corresponding folder. This was much more maintainable. It helped us have all the configurations in one branch, and it was easy for me to compare configurations across environments. I could automate it, saying that if anyone is adding a new key, we'll put in a validation which will ensure that the key is present in all 3 environments. So these kind of validations to ensure we're not doing any kind of manual, we're not missing anything while we are adding new things. Those things could potentially be added, and that kind of helped evolving that particular pipeline much better. So that was related to config and secret management. I think the point to note here is a great target. The target, the target system where you want to put the configs might be very easy to choose, or maybe it's difficult. But once you choose it, also decide on how are you going to manage the configs, what is the source of truth, what all do you need to ensure that deploying a config is not going to be disruptive. Right? So think about that pipeline, and driving it via source code is a brilliant option, as what we felt from our own experiences. I think that's it. from related to config and secret management. Okay, network and security. Okay, this is a tricky one. It's gonna take a little time. I think we'll start with how we started off. This is the initial state, right? So don't worry about the icons. I'll put my cursor over it as and when I speak about the corresponding tech, right? So initial setup, we were also in the process of exploring different capabilities provided by Google Cloud GCP. So we also started by saying that we will have one GCP project per environment, and within that project we will have one VPC. VPC is virtual private cloud. It's kind of a private network inside GCP. So once you have a virtual private cloud, we will see we had some subnets within that. And subnets, we will have some subnets within that, and within that subnet, we'll create any of our compute resources, be it a virtual machine, be it a Kubernetes cluster, anything, be it a load balancer, an internal load balancer. It could be anything that we create within that subnet. And this was one environment, and we had multiple teams or maybe departments. All of them were kind of using this one setup. This was okay when we initially started off because there was only one team or one department which was using the setup. But over a period of time, we started getting more teams and more department requirements to move their components also into this new infrastructure. Now that is where the problem started. The problems were there were multiple problems. Okay, let me try to iterate a few here. So one of them was access control. Okay, anytime we wanted a new team to be onboarded, there was no way we could segregate the access in such a way that only components that team needs to maintain will give access to that components. That became very, very hard. I don't think that was even possible with our batch provided by GCP because it was all in one project. Of course, we could have given different roles, but then it doesn't reduce the area of the reduce my visibility into the components which I'm not supposed to see. So it's not about an issue of not giving access. We are happy to give access. It's not about not giving access. It's a noise, right? If I'm seeing things which I don't want to see, what is the point? So it's an unnecessary noise from anyone's perspective. Like I'm seeing a lot of things which I don't even care about, and potentially could lead to manual errors, which could potentially impact all our systems, right? Imagine if we had 2 or 3 teams in the same project. Any change in any of those teams' components is a potential risk to all the other teams because it's all being managed in one central place. So this became a problem. This started becoming a problem. We started stepping on each other's toes, and there were potential small disruptions that happened. And that's when we realized, maybe we're not doing it right. We need to rethink about this. Maybe there's something that we are missing on. So we went back to the whiteboard and started started writing down what do we want to achieve. Let's talk through that. What did we want to achieve, and why did we want to achieve that? So we said, each team should have their own network, and within that network, they should be able to create any kind of compute resources. Be it a virtual machine, be it a Kubernetes cluster, be it a load balancer, anything, they should have the control or the access to go ahead and create it. And there should be a way for them to communicate to the external world. Like mentioned earlier, security. Security is of utmost importance to us. So one thing that we initially made clear is we will not have a public IP for any of our machines unless it's absolutely required. Right? So we said everything is private IP. So with that concept in mind, when we started looking at this new requirement, this network, the components in this network, if it has to talk to outside world, if it doesn't have a public IP, there has to be an alternative. Right? So CloudNet is the solution that GCP only gives us for allowing a virtual machine without a public IP to talk to the outside world. So this small icon here is the CloudNet, and this is a load balancer, this is compute engine, and this is a network. Right? So this is with regards to one team. So they have their own network, they can create their own resources, whatever it be, and they'll also be assigned a CloudNet through which any components within that system can talk to the outside world. Now, like this, we'll have multiple teams. all good. Each of them have their own network. They have full control on creating their own resources. This is a Kubernetes cluster icon. Once this is there, one more thing that we wanted to attack was we didn't want to distribute the network rules all over the place. We wanted one central place where we could control all the networking rules. The reason was simple. We considered network as a very strong line of defense from a security perspective. So any change to the network should be thoroughly reviewed, should be thoroughly discussed. Unless it's absolutely required, we will not open something on our network. And we also wanted to go via the principle of least privilege, where we'll only open what is required, right? Don't go ahead and open blindly everything. That is not at all secure. So, and we also wanted a network to be a slowly moving, component. We don't want changes to be happening to the network all the time. So we wanted to invest a little bit time on trying to come up with the right design for the network to ensure that it's not a fast moving component, changes to it once in a while, but those are required because of a new requirement and it's thoroughly reviewed and everything. With that in mind, we didn't want to consider these three as three separate VPCs. What we did is we combined all of them into one VPC. Now, the fact that these three were three different projects and we had one VPC controlling all the three networks in the three different projects, we could only do it by shared VPC. So shared VPC is another capability that GCP provides you, wherein which you could have a host project where you control all the network related stuff, and you have service projects, which are these three buckets here. And subnets can be assigned to the service project. So I could have a data team in my organization, maybe an order management team, a payments team. We could assign projects to each of these teams, assign a subnet to them, and they will have full control on creating the required resources within that subnet. So this kind of kept it separate. We were able to give that autonomy for the teams to get the resources up and running without creating much issues to the other. And the networking rules were still central, and we had thorough review through that, and that kind of helped us in securing our perimeter also from a network perspective, right? Now, okay, fine. So that is how it evolved. We started from one single project and one single VPC to a shared VPC with multiple projects, and it has worked well so far. The network is very kind of rigid. Rigid as in it's not like it's closed for changes. It's open for changes. It's thoroughly automated. We can change it, but it's very unlikely that the changes will happen in quick successions, right? Very, very small amount of changes comes into play. One more thing that we need to call out here is if anyone is going ahead with this kind of a design, we need to be very clear on how are we going to divide the IP ranges to the different subnets. So you need to do a rough math on how many nodes are going to be there in this particular subnet, and if that subnet is going to host a Kubernetes cluster, then you need to understand how many pods are likely to be run on that Kubernetes cluster, and maybe how many services are going to be on that Kubernetes cluster. The reason is Kubernetes is a bit IP hungry kind of a thing, wherein which it requires a lot of IPs, especially when pods come into picture. So you need to understand you need to do some capacity planning, like what do I foresee. Based on that, you need to divide the subnet and say that I have my primary IP range satisfying so many nodes, and so the Kubernetes cluster can have so many nodes, and then I have my secondary range, which is for the pods that will be provided in such a way that I'll have to do a calculation. I have n number of nodes and I have m number of pods which can be run on one node, so I need to have m by n IPs for to be on the safer side. I might not be running m by n pods, but just to be on the safer side, right? It's very hard to change these things once it's in place. So you need to think a lot about it. So the team did spend a lot of time trying to come up with this subnet splitting. And we kind of split the subnet and assigned it to the teams which we have visibility on. and the teams, and from within that subnet, we can again split it into smaller ones. Okay, so there's no what do you call it? Nothing stopping us from doing that. But this top level splitting has to be done with some thought process and some analysis by looking at the future, doing some extrapolations and everything. So that was one exercise that we had to spend a lot of time on, and it has paid off. We kind of in a better position from a subnet perspective. Of course, there are some things missing here and there. But once we were in this new infrastructure, new design, I think it has been over a year now, almost over a year, and we have been in this one. It has been doing well, no complaints so far. So that kind of helped us a lot by putting the effort that we put in have rightly paid off is what we believe. I think that is from a network and security perspective. Kata, did I miss something?
No, good.
Cool. So yeah, that's it about network and security. Let's go to the next one. Kata, over to you.
Yeah, I think so. While we spoke about prep, it's not just about whiteboarding or coming up with design documents and architecture diagrams and whatnot. It's mostly about thinking through what this kind of a transformation require, and have the necessary things in place. That she talked about network security. We spoke about observability. We spoke about logging. All of those things need to be in place so that when we start migrating the actual services, we have great confidence that we are going in the right path. And then we had to take a call on how do we migrate. We have 80 plus odd microservices in our three different cloud providers across VMs, different technology stacks, and all of it. Yeah, we had a great fundamentals setup. Now the biggest question that we had to answer was, how do we migrate? What gives us confidence? What gives us faster feedback, right? There was multiple options on the table. Pick service by service. Maybe pick complex services at the beginning so that it gives you confidence. Now, don't start with easy, because you may never get the kind of feedback that you're looking at with easy services. When I say complex, a service which has a lot more dependencies and a lot more third-party dependencies, the dependency graph could be probably higher than maybe a stateless service with very little dependencies, right? So that was one choice that we had on the table. The other choice was, that could have given confidence to a developer and maybe a technology team, but definitely won't give the confidence to the business, because they want to make sure that the business is not disrupted, right? Then we thought, how do we balance the both? And we came across this other approach where, how about picking a functional area and then deploying it into or then taking that through transformation journey. Maybe it's an order management flow, or maybe it's a user onboarding flow, or maybe it's about how you compute, how much the right cost and what should be the payouts for the captains, right? Pick any of those flows. That way, I think the conversation from tech to business would be, hey, we have taken care of these critical flows, and these are the flows which are yet to be transformed. So the business knows what to expect from this entire transformation journey as well, right? That sort of, felt a nice balance between choosing between complexity versus choosing the kind of services so that we understand the impact. Because if we move one service, we don't know what is the impact if that goes wrong, right? Apart from X amount of errors, we can't really have a conversation with the business saying, hey, you had an impact on your payroll, or you had an impact on your orders, or you had an impact on your onboarding. And the other approach, obviously, we was on the table, but we ruled it out very, very initially, is one shot. Have everything ready and just one shot do a flip. We felt that that's probably not the right approach, because we always believe in evolving our architecture, learning on the go, be pragmatic about our design as we go along the journey. So we ruled that out, that one shot thing, really quickly, and we ended up going with the second path, which is move a bunch of services which are mainly bounded by a domain context and has reasonable complexity. That should give us confidence, and that should give business confidence. And we started our journey like that. And once we made some of our critical domain context related services as transforming and migrating into the new world of infra, and we had a lot of things automated, which Sri is going to cover in the next slides, which helped democratize even this transformation. It didn't needed a small team of DevOps who are focused on this transformation sit and do it. We could ask individual functional teams and the domain teams and the business teams to say, hey, go ahead, your services. Here's the plan. Here's the checklist which she's going to talk about, and here's the approach. Go ahead, you can run the show. This is how you monitor. This is how you ensure things are in the right place. That's how we took this path. And it's important for you to choose the path. And again, we're not saying this is the right path or this is the wrong path. You have to consider all possible options. You need to deliberate on which works for you. What is the main thing that you're looking out for as part of the transformation? Is faster feedback more important to you, or is taking the business along the board during this transformation is most important for you, or doing it in one shot, having thorough testing is most important to you? I think it depends on your circumstances as well. And we picked a combination of second and first. We started with second so that we get confidence. Oh, actually.
Yeah. So I think a checklist is always a brilliant way of figuring out if we are ready or not, right? Be it for migration or be it for something else. I think it always helps. Like checklist is very, very helpful when we want to figure that out. We also had a checklist. So it's not like we came up with the checklist, foolproof checklist the first day. It was an ever-evolving one, as and when we had an initial one. And as and when we started deploying more and more services, this checklist started kind of getting more and more refined. Many things went out, many things came in, and so on, so right? So some of the things like checklist depends. Okay, so I don't think the checklist will be same across organizations and across applications. It depends on like how have we structured our infrastructure, what is that application doing, what are its dependencies, and so on. So a lot of things that kind of makes the checklist kind of different across applications and environments and everything. But these are some of the things that kind of helped us, and we started off with initially, like having a health check for a service. And hooking up this health check to the readiness probe and liveness probes, so that when the moment we deploy a service into Kubernetes, we kind of get to know, is it able to talk to all the databases that it's supposed to talk to? So that kind of give us a little bit more confidence on, hey, the service is up, it's able to talk to the database, fine. Now should be okay unless we have missed something on the configuration sites, or maybe something which we have not covered on as part of health checks, right? So connectivity checks is kind of an extension to health checks, where there were certain services which were talking to another third-party service, so there might be whitelisting on the third-party services and so on. So we kind of had an automated tool which would run inside the cluster and then get these configurations and try to check if all the connections are available or not. So we had something like that. So before we deploy every service, we would run that tool and say, hey, all the components that the service can talk to needs to talk to the cluster. The connectivity is open from the cluster view, so we mark it as done. Node Affinity, because we had segregated our node pools and we wanted all the services to be going ahead and sitting in specific node pools. Resource person very important because that has a impact on your services and how one service might eat up to the resources of others and everything. Right? It's essential that you configure it right the first time. Maybe if you're migrating from a VM to a Kubernetes world, easiest option is to give the same number of cores that we had in the VM. Maybe start with over provisioning, and then maybe over a period of time, looking at the trend, maybe start refining it. Right? That's a better idea. That's what we did. Config dev, again, as I mentioned earlier, we were making drastic changes to how configuration is being managed. So every service, once it is moving to this new way of getting configuration, testing it after deployment was very, very risky. So we kind of had a solution in which they could do the diff from within the machine itself by talking to the console and vault and the target environment. And then we could compare the diff and ensure, hey, what we are going to generate in the environment is same as what we expect. So those kind of things could be done. Deployed and tested in lower environment, I don't think it has to be mentioned. It had to be deployed somewhere and tested. We had a staging environment where we deployed and tested. Also, when we wanted to pick up a service and migrate it, like first 3 or 4 services, when we started doing it, we started adding a health chart for Java service, Node.js service, a Golang service. again another Java service is coming, we are doing the same thing. So we definitely found out, hey, there is a repeating thing. Anything that can be repeated has to be automated. That was a general thought also. So this was kind of a repetitive work. So we created an automated tool to generate help charts, and that kind of generating help charts based on the tech stack, be it Java, be it Node.js, be it Golang. We had slight differences in the help charts for these services. That's why it was dependent on the language. Yeah, with that, it kind of gave us a confidence, like as a team, when we started off with the migration, it gave us a confidence. Hey, if we complete with this checklist, we're kind of sure that the service is going to work. If it's not working, then it's something that we have not foreseen. Then that will again come back to the checklist as another item, which will start getting evaluated from the next time onwards. I should accept we didn't get it right the first time, or maybe first 10 times. It kept on evolving right over a period of time. And again, as Kata mentioned, we can't do 80 plus services with such a small team. We wanted everyone to start contributing to it, right? So so this was another thing wherein which this could be given to a team, saying that, hey, once you satisfy all this, just try deploying. It should work. And if there is nothing if it's not working, we'll come and debug and then find something. And if that has to be added back to the checklist, it'll be added back. So that's how the readiness in checklist evolved over a period of time. I think it's essential, very, very important to have a checklist, without which it's very likely we're going to miss something out. And because it was a migration phase, we can't automate everything while the migration is going on, right? That's why the checklist also plays an important role.
Yeah, and we also had to train the teams because not everyone was aware of Kubernetes and the new technologies that they had to adopt to. I think we also invested in making sure we had the right training materials compiled or aggregated. Some of them we built on our own, and literally had training hands-on sessions with the team, so that the teams, when they're that's another thing many companies probably underplay in terms of, they would assume that, just because you have automation in place, people will learn new technology on their own. But the fear of not knowing would probably doesn't motivate them to take it on as a challenge. Rather, they'll find reasons to keep deferring it, right? So we attacked it even before that comes up by saying, like, let's make people comfortable. There may be certain people who already knew the technology. Maybe there are people who aren't aware of some of these technologies. Let's take some time out, get them comfortable with some of these technologies, so that when we ask them, hey, you know what, we've done the fundamentals, we've automated whatever we could. Now it's your turn to pick some services and start migrating. They feel more comfortable and they feel like, yes, I know what we're talking about. Let me take it. Of course, they needed some help, but that sort of boosts their confidence that they could own, and they're not afraid of what's happening with the transformation. Completely one thing before, and now I don't know how to look at logs. I don't know how to deploy. I think to alleviate all those fears, we invested time in preparing the training content and did train some of our teams.
Cool.
Yeah, I think while we started this journey, one thing we probably made a mistake early on is not setting the right business expectations. Definitely, it's a big lesson that we have learned. As you could see on the left picture, during this transformation or a transition, because in order to make sure we have easy fallback options, in order to make sure if something goes wrong, you don't have to disrupt the business, you'll end up creating some bit of redundancy, right? When you're transforming, it's not that you're going to kill the old machine and have just the new bunch of services on the new infrastructure, right? You still keep the old ones just in case if you have to roll back really quickly. And also to remember, we kept saying the old ones are not automated, so we couldn't have turned it off and hope that we can turn it on if we had to roll back. So literally, we incurred double the cost during the transition period. You could see the graph. The cost suddenly increased, and the business started panicking. Hey, you're talking about transformation, you're talking about auto scaling, auto healing. I'm hoping that all of that should save costs. Like, why are the costs increasing, right? And that's when we had to we realized that no, we should have set that expectation in terms of during this transition, especially that period, you will incur a slight marginal increase in the cost. But in long run, it does come down, and it does come down much better than what it used to be when you started your journey. That was a promise, and I think we lived up to that promise in terms of our cost today is much cheaper than what we were 1 year behind when there was absolutely no automation and whatnot, despite the traffic on our systems have increased maybe 10x compared to the last year, right? That's one. So do set that expectation if you're going through that journey. And the other one is while we aspire to do everything and with all the planning preparation that we're talking about and all automation we're talking about, while we aspire to have zero downtime and no disruptions, you will end up making mistakes. You will end up overseeing some things. So you will end up causing disruptions. And setting upfront that no, hey, you know what? We'll try and minimize as much as possible. We'll try and pick the timeline of deployment, whereas the impact on the business is really, really minimal. But we still are letting you know that no, there could be a possibility of disruption, and we'll tell you what those kind of disruptions are when we went on with that journey and what we learned from that. But it's unless you're really lucky and you've done every single possible thing in order to make sure nothing goes wrong. Especially if you're going faster in this journey as well. Like I said, we probably did all of the transformations in a matter of 3 to 4 months. The speed was also at play. So we had to prepare business in terms of disruptions. Probably we hadn't done a great job of that. Something, if you are going through that journey, I think do remember to do these two things. That will save you a lot of time. Go for it, Sri. Yeah, then we started on with execution. I think, like I said, again, the preparation was not just about whiteboarding and design documents and whatnot. It was more about preparing your infrastructure, preparing your teams, preparing the mindset, getting the skill sets up to preparing the business. That's what we meant by preparation, and not necessarily just putting it on paper and say, hey, here's our strategy, right? And now when we started on this execution, I think one of the main reasons that we are giving this talk is not just talk about how a piece of technology works. It's more about how we went about during this transformation. What are some of the mistakes that we have done, and how did we learn about it? How did we evolve? So that if there are any of you out there who's trying or going on a similar journey, firstly, you're not the only ones. There are people who have done this. So have that courage to do it with confidence. And two, maybe take some of these tips and tricks so that you don't make the same mistakes. I think that's the whole intention. Over the next few slides, I think we're going to talk about some of the mistakes that we probably have done. And if you are using the same set of technology and if you're taking a similar kind of path, just be cautious of that.
Cool. Yeah, first move. Okay. So that was a very exciting time when we actually got to move our first service to the Kubernetes cluster and started routing traffic. It was one of the most exciting days in Rapido, I guess. Before I go to what we did during the first move, let me make one thing more clear. So, like in the current system, like almost 90% of the services had an Nginx in front of them. Before we started migration, we also ensured that 100% of the services do have an Nginx in front of it, so that routing traffic is easier, and we had one place to control the traffic. Like N% of traffic is getting routed to the new system, whereas in the remaining percentage is still getting routed to the old one, right? So the setting up Nginx was very important. Routing was simple. So the drill was this. Like initially the whole team would sit together and then start routing very small percentage of traffic to the new system. Look at monitoring systems, see if how the error rates are doing, how the success rates are doing. Look at Nginx metrics, look at logs, see if the response times are good. All these are being monitored closely while we initially route the traffic, and monitor it for a while, and then we keep on increasing it in steps till we reach 100%, right? Of course, if the monitoring gives you bad signals, roll back, switch it back to the old system itself, don't proceed. Go back, analyze, figure out what is the issue. If it's something that can be fixed, fix it and come back and do the same drill again. It's kind of normal to go via that path. Like anything that you deploy, you'll monitor and then you'll figure out whether you need to roll back or not, right? But one thing that we one scenario where in which we missed out something is, like, this is what made us realize, hey, monitoring, looking at error codes or success codes is not just enough, right? Because there was one scenario where in which the response codes were all good, it was doing good. So we kind of it was like one of the initial services, we kind of got a little bit motivated and excited. We started pumping up traffic, more and more traffic. But then after some time, issues started getting reported from the ground. There was some issue going on, so and so, and it was related to a component that we had just migrated. So definitely, it started ringing alarm bells, and we reverted the traffic. Now, when we went back to the logs, like we went to the monitoring setup and looked at the code, response codes, everything was good. The servers were performing really well. All was good. That's when we thought, okay, let's go and look at the logs and see what was happening. There were definitely logs which were saying that something was not right. There were error logs which were pointing to something which was not going right. But we completely missed to look at the logs. We are kind of dependent on the monitoring thing, and we kind of ignored the fact that, hey, we had to look at the logs. So again, that was a learning. Like we didn't stop from there. Two things we learned. Okay, it's not just monitoring. You need to look at the response codes. You need to look at the duration. You need to look at maybe how the CPU and RAM is doing. It's better to look at. You need to definitely look at the logs. Also, look at how is it printing out errors or something. And we made that part of the drill. And the second thing. So we made that part of the drill to ensure that we look at the logs also. The second thing that we figured out is, okay, maybe we shouldn't speed up so much, right? So the pace at which we were increasing traffic, maybe it was a bit too much. I think we should cool down. We started categorizing services as critical, less critical, maybe not critical. I don't think there was anything which was not critical. All the services were either critical or less critical. So we kind of said for critical services we would spend a day initially to start with, spend a day to maybe get 100% of the traffic in place just to be on the safer side. We of course increase this pace after a period of time, and for less critical services we might decrease the frequency between the steps, right? So that's how you evolve, and you try to get the feedback, try to change the setup, you drill, and go back and try to ensure that you maintaining the pace at which the migration is happening, as well as you're cautious enough to not cause business disruptions, because that kind of was not a good experience when that happened. So that is with the first move. I think there's nothing else that we had to cover here. Kata.
Yep. As soon as we started with the first move, we were like so happy that we had our lessons, but we were like, we've cracked it, and we started moving more and more workload onto the new infrastructure. And then we started hitting hiccups, and we hit our second roadblock. I think given our target infrastructure was Kubernetes, I think kubedns is one of the components which helps you resolving the coordinates of every different other service that is available within the Kubernetes, right? So it's mainly a DNS resolver, which comes along with your Kubernetes, right? One of the biggest assumptions that we have made was, or rather, one of the misses that we had, we didn't anticipate was, given the Kubernetes we were going with was a managed service, we were assuming that it's ready for a production kind of a scale. Maybe it is for many of the production workloads, but given our scale, it wasn't apt, right? One of the issues that we saw was the DNS wasn't able to handle the kind of load that we were seeing in that particular infrastructure. We started getting timeouts. DNS was not getting resolved, which had an impact on one service talking to service A, talking to service B. It took a while for us to figure this out, because when we looked at service B metrics alone using a monitoring, there were no errors in the logs. There are few services who are talking to service B and for the same functionality, and it seems to be working fine. It was only service A which was not able to reach service B, and we were wondering what the heck is wrong. The service B is the one which was recently deployed, and everything seems to be fine within. And there are certain parts from other services for the same functionality, and it seems to be working fine. We went clueless, because our entire focus was, did we do something wrong in configuration? Did we do something wrong in our application? Only to realize after digging further that it was a kubedns which was causing an error, and we found that error like maximum concurrent DNS queries reached, because by default it only supports X amount of concurrent queries. It allows you to configure them. I think the bottom snippet tells you, some of the key parameters that you could watch and configure, so that it allows you to scale your DNS depending on your workload. The main important lesson that we've learned is never assume just because it's a managed services, it would be apt for production recommended settings, right? You need to understand your workload, you need to do your capacity planning, and you need to also understand what are the internal components. For example, Kubernetes managed service, it has tens of internal components, right? Like it has etcd, it's at kubedns, it has API server, It has persistent volumes and controllers and schedulers, all of them. It's important for you to understand, though it is a managed service, you don't have to manage it yourself, but you still need to understand how they behave with different workloads, what are their recommended settings, and does the default settings good enough for your workloads, which is something we probably learned in an hard way. There's also an alternative that Kubernetes recommends, which is Core DNS. However, with the version of Kubernetes that we're using, KubeDNS comes for default, so we never explored. After fixing this, we never had a strong reason for us to move to Core DNS, although it offers some of the better functionality compared to KubeDNS. So here we're not recommending KubeDNS. We are just talking about the way you need to look at configurations and settings of managed services, especially if your workloads are not very minimal. Go ahead, Phil.
Yeah. So the next hiccup was with CloudNet. As mentioned earlier, we had decided that we'll not use public IPs at all unless it's absolutely required, right? So we went ahead and created a private Kubernetes cluster in the spirit of that. So all the nodes, if there had to be a connection to the outside world, it had to be via CloudNet. So CloudNet allows to establish that connection. So again, like Kata mentioned earlier, the same mistake as what we repeated here when we went ahead and set up CloudNet. We understood, hey, it provides the solution. We could select the external IP addresses, how many do we need and all. But to be frank, we kind of overlooked certain configurations. And it worked initially well, like when we had some number of services running, it was working all cool. But some of the heavy services, when they started coming into picture, which had to make a lot of outbound calls because of integrations with other components and some other reasons, when they had to make a lot of outbound calls, issues started coming up slowly, right? The starting was services were saying connection refused errors when they were trying to talk to the outside world. It took us a lot of time again to come back to the fact that, hey, it was CloudNet causing us. We started with service logs. We had Istio within the cluster, so we kind of started suspecting it was anything to do with Istio. And when we couldn't find anything there, we kind of went on to other Kubernetes related stuff. Is there anything wrong with Kubernetes? And it's after a lot of analysis by looking through all the components layer by layer, and that's when we finally reached NAT. And when we started looking at stack driver logs for CloudNet, we started seeing these logs saying that, okay, connections are getting dropped. That kind of said, okay, fine, NAT is having issues, fair enough. Let's understand why is it having issues, right? So the one thing that we overlooked is the calculation that CloudNet does to come up with the number of ports that had to be allocated to a VM. And what does that mean? Like if I have n ports assigned to me as a node, what does that mean? So there is a variable called as ports per VM. So you need to kind of understand how many VMs do I have and how many ports do I need per VM. Based on that, we need to calculate the number of external IP addresses that had to be assigned to the NAT. When we say it has been allocated n number of ports, what it means is at a high level, you can make n parallel connections to one destination, right? There is a way in which they calculate the uniqueness of a destination, uniqueness of a connection and all. So this was the issue. So we fine-tuned it. We understood this was the issue. We started working on it. We started doing a capacity planning on how many ports do we need. Based on that, we calculated the number of IP addresses depending on the number of VMs we have. We also extrapolated it maybe next 6 months or something, looking at how the number of nodes is increasing. So we came up with numbers. We started increasing the number of NAT IP address. Soon it became very unmanageable, right? The IPs are just increasing and increasing. The errors are reducing, but it's not completely going away. We understood, okay, this will work, but it's not a scalable solution. Two reasons. One is it keeps on increasing, and of course, there are limits on NAT IP addresses and NATs that you can create. Second is, take a case where in which if I want to whitelist these IPs at a third party, if my workload is sitting within the Kubernetes cluster, it could potentially go ahead and sit on any of these nodes, and all the NAT IPs are potential candidates for this guy to this node to use to make an outbound call. So that became very hard, causing issues when we were whitelisting. That was the other problem. It became an overall unmanageable solution, right? we started thinking about it. So we found a solution by, we were thinking of a solution wherein which can we route the traffic like these kind of external high RPS calls. Maybe is there a way we can route it not via CloudNet? Can we bypass CloudNet in that scenarios? We were able to do it. We leveraged our service mesh Istio to achieve that. This is at a very high level what we did. Like any service which is calling a specific target, which is out in the internet, and if we want to bypass CloudNet, we would configure Istio to route that traffic to an egress proxy, which is a VM, which we provisioned using VMs and Nginx, and have a public IP assigned. Right, the moment it has a public IP assigned, it bypasses CloudNet and the traffic directly goes out from there. This is how we solved that problem. But again, the learning was you using something like I mentioned, if it's a managed service, fair enough, the default settings will be good for starters, but it's better read through the documentation, try to understand what each of the configuration means, try to map it to your workload, see if any of them have an impact on your workload, and based on that tune it. It's better to do that exercise first than being sorry later, right? That's the major lesson that we learned. The whole setup, there is a blog also on our Medium, publication on how we did this. It's quite detailed in the here. We're just mentioning the high level overview if you're interested in looking at it. That's related to the CloudNet. To the next one. Yep. Tunnel.
Sri, one sec. I think we are running out of time. Divyo, is it okay if we take another 15-20 minutes to close it off?
Yeah, sure. You can continue.
Thank you. Go ahead, Sri.
Cool. Tunnel. Okay. Let's understand why we wanted this tunnel first, right? So as mentioned, we were doing a migration. So we had a legacy network and we had created a new VPC. So while we were moving components from the legacy network to the new VPC, there had to be communication between the VPC and the legacy network, right? So if you, and because we said no public IPs, if anyone from the legacy network had to communicate to the new VPC, it had to be via private IPs. Then we had to set up some kind of a tunnel. So if both of them were VPCs, we could have set up a VPC peering. Because one being a legacy network, we had to opt for something called as a VPN tunnel. So this is provided by GCP for enabling connections between a legacy network and a VPC. And we also went ahead and set up a tunnel. Actually, we didn't even know that tunnel was an issue, but because the issue actually happened at a very different place. So I'll give you an example. So we had an API gateway. We still have the API gateway. So the API gateway was sitting on one side. I think the API gateway was on the new VPC, whereas in the databases that the API gateway was supposed to talk to was sitting on the legacy network. And occasionally we saw saying that, okay, the API gateway is not able to connect to the database. And there was connection refused errors. We did anything and we did multiple things on the API gateway, try to understand how it does the connection. We tried to go through the source code and everything, try to see how the connection is being made. We started tuning the API gateway just to ensure that we're not doing anything wrong in that aspect. We also tuned databases, the operating system, the machine on which the database is running. We did a lot of OS level network tuning and everything. Still, occasionally, there were connection drops. That is when we started digging a bit deeper, and the tunnel finally going through each of the components, tunnel came into picture. And when we started looking at the tunnel monitoring, what we found out is there were connection packet drops during the exact time where we were seeing the connection failed errors in the API gateway. So the packet drops were happening because of two reasons. One was there was a bandwidth limitation. Tunnel has a bandwidth limitation, so we were kind of crossing it, so the packets were getting dropped. The other one was because it was not we hadn't set up a highly available solution. There is an option to set up a highly available solution, but we missed to choose that option, and we had set up one single tunnel, which was a point of failure, right? So during some maintenance event or something, there could be occasional disruptions to this tunnel, and because it was serving one of the major links in our whole application, like API gateway to database, without API gateway, nothing is going to come in. Because it was a major component, it kind of caused a huge disruption for us. So the learning is, again, of course, if you're using a service, be it managed or something else. Try to see if there is a failover setup that we can create. If yes, definitely go for it, and also ensure that there has to be the right, like try to understand the limitations if there are any, because that's clearly documented by most of the cloud providers, right, including GCP. So try to understand the limitations, see if that limitations apply to us, because we might not oversee it when we just glance through it, because it requires a little bit of thinking and analysis on the current traffic and everything to come up with scenarios wherein which we'll see, hey, this might impact us. It requires a little bit of analysis. But it's worth doing it rather than facing a downtime is what we have seen. So we kind of go through that process now when we choose a new technology. We had two options once we understood this problem. One was to go with the highly available tunnel, or start reducing the dependency on the legacy network. Since we anyways had plans on decommissioning it, we accelerated our migration from the legacy network to the new VPC, and now we have very, very minimal dependency on the legacy network. That's the path we chose. But yeah, those were the learnings from this one. Cool. Tata.
All right. So I think we spoke about some of the migrations of stateful services, which are microservices, which doesn't hold state along with it, right? They're pretty stateless, and with just that, we had so many hiccups when we started doing it at scale, right? And when we talk about stateful services, like the databases, the Elasticsearch, the caches, and whatnot, it has its own challenges, right? And two such main components that we had in a workload was Elasticsearch and Redis, right? And they are very critical components. It's almost like every single as and when there are captains available on a platform, those are the places where we try and keep their current location, so that whenever there is a request from a customer, we serve from them, right? It meant that if you have to migrate from DigitalOcean to GCP, it meant that taking backups of those. These tools do provide some of the backup and recovery mechanism, but that requires a brief period of downtime, right? Maybe a few minutes, but given our business was 24/7, we couldn't even afford to do that, right? We were looking for options where how do you do it real time, especially across two different cloud providers. While they are, some of them are horizontally scalable, one option could have been like, can I expand that Elasticsearch cluster across two different cloud providers, or Redis across two different cloud providers? Probably not recommended, given the constraints of the tunnel and all that Sri just mentioned. So we didn't have enough confidence to probably expand the existing cluster across two different providers and do that kind of a transition. So we were looking for options where we could do application level replication, right? So the one you see with the probably the red background is our services on DigitalOcean, and we had an Nginx. I think that's pretty much a norm that we had for any of the microservices printed by Nginx, because Nginx could control traffic across multiple instances of that services, right? And not only that service was getting traffic from other services by Nginx, there were some services which were probably talking to that service directly, and because of the lack of automation, it wasn't easy for us to figure out the entire dependency graph, right? 100 plus microservices, very few people. It was very hard to, the knowledge itself was faded away over a period of time. We were looking for how do we make sure every single traffic that is coming into the service on the DigitalOcean is replicated onto the target service, and get that confidence before we do a quick switch at a Kong level. Kong is our Edge API gateway. So that there is, and this switch should happen in a matter of microseconds, not even milliseconds, right? So that was our goal. And we explored Nginx mirror module. It had its own challenges in terms of if you were to mirror traffic both for one service in one cloud provider and another service, even if the replicated, the mirror service, which is on the right side, had issues, it induces the latency cost onto your primary traffic or primary service as well, which is something we couldn't have offered, right? Because right now we are just doing validation, and at the time of validation, why would I incur the cost on my business itself, right? That's when we encountered this nice tool called Go Replay. It's called Geo Replay, built by Go, which is a fantastic tool if you have to mirror any kind of HTTP traffic. Maybe it does support TCP traffic, but we never had to use it. Any kind of HTTP traffic being received on a particular port, and route it to a completely different infrastructure or different service. It could be in your same cloud provider or different cloud provider, different machine, doesn't matter. You could mirror it to a different target, right? That came in really handy, and we use that Go replay. That's the little blue circle that you see on the left side, and we ran it for a couple of days and started with some automated scripts. We were able to validate for a given time period everything that's going into Redis on the DigitalOcean cloud. Is it exactly the same on the Google cloud? And the same is with Elasticsearch, right? Because it was a critical component, we had to ensure the replication is happening real time, and there's not even a discrepancy of a single document, right? That gave us, I think initially there were some issues. We fixed something on the application side to make sure, okay, all traffic is being routed. And that gave us a lot of confidence that we could actually start migrating stateful services with this approach, right? And once we had that, we ran it for 2-3 days. And the right side one is not getting any traffic from the application. As you could see from the picture, it was just mirroring the traffic and looking at the volume. And every day after validation, we used to clear it off and get another day's traffic, so on and so forth. Right. Once we built that confidence, all it took was a simple switch at a Kong level to the Nginx on the right side, and we were able to migrate huge clusters like Elasticsearch and Redis onto the new cloud provider. This is something. Maybe there are other ways to do it. Like I said, we had constraints or challenges to do with expanding the cluster across different cloud providers given in our use case, and we went with the path of application level replication of traffic and ensuring that all the migration is happening, all the data is there, and all of it. So this worked out pretty well. Do check out Go Replay if you have something similar use case. I think quite handy tool, and we use it extensively across our board. Even for some of your normal testing, if you want to understand what's happening in production by replicating the traffic into your lower environment or whatever, this is a tool that you could consider using. Go ahead, Shay. So similarly, at another stateful workload we had to migrate was Kafka, Apache Kafka. And I think like probably we touched upon earlier, our entire system is built as microservices since the beginning, even before we started this digital transformation. It was built for cloud. It's just that there was a lack of automation and the lack of scalability aspects and whatnot, and the consolidation was required. But given we were always microservices, there were two standard integration patterns, synchronous and asynchronous. Wherever we could afford asynchronous integration pattern, we used Kafka as a streaming platform, and that Kafka was sitting in DigitalOcean. While we started moving, all our stateful services like microservices and other Elasticsearch, Redis, and all of it, suddenly there was the Kafka is sitting in DigitalOcean, but maybe 60-70% of rest of the workload is moved to GCP. It's almost like, from GCP, you're going out to DigitalOcean when you publish a message. And to subscribe again, you're going to DigitalOcean, which didn't make sense, right? It was high time we start looking at how do we migrate Kafka without incurring a downtime. So the two approaches we considered. The first one was like a typical thing that if you just Google, you'll find tons of articles where just add more nodes into your broker. Increase your replication factor so that all of your nodes have the same message, and then the new nodes are provisioned in the new cloud or the new set of infrastructure if you want to, and then point your services into the new one and reduce the replication factor and get rid of the old broker. The beauty about Kafka is if you kill your master node, if you have set it up in a cluster setup, any of the other nodes would quickly pick it up and start running as a leader. Right, because of its seamless ability to pick up as a leader for all of the partitions, that was a viable option. In our case, that wasn't because some of our services like Node.js weren't tolerant to this partition reassignment. It used to lose connections intermittently and all of it. And at that scale, we couldn't have afforded to lose connections, and at the same time, we couldn't have waited to make changes in maybe a few tens of microservices. Figure out the right Kafka library or make it tolerant to connection loss and whatnot. So we were trying to address the problem at an infrastructure level itself. So the second option we explored was Mirror Maker. Again, it's a solution from Apache itself, which is prominently used if you have to replicate your entire replicate everything that is coming in one broker into another broker. Doesn't matter that other broker is in the same cloud or different cloud or whatnot. So that initially looked promising in terms of it could mirror everything from DigitalOcean to Kafka. But as you could probably some of you might be thinking already, like, as we could start moving consumers, the challenge would be managing the offsets, the commit offsets. So when the consumer moves from one broker to other broker, you also had to manage to migrate what was the last commit offset that a particular service had on broker one and move it to broker two, which wasn't an easy thing. This is about maybe moving at another topic seamlessly into another broker and all of that. Anyways, we were still exploring. Both of them had pros and cons, but there was an unfortunate incident which worked out for us. Fortunately, there was an outage in DigitalOcean Singapore at that point while we were doing this, which means pretty much the whole Kafka broker was down. And because of all the automation that we have built initially, we took that as an opportunity. Forget mirror maker, forget expanding. Anyway, the whole of Singapore region was down and most of our workload was in Singapore. So we took that downtime of DigitalOcean as an opportunity to migrate the whole broker and use the whole automated script to set up the new broker. We pulled all the teams together in that 1 hour time and had all the systems start pointing to this new broker. So we really didn't go with any of the two approaches that we discussed, but those are things that you could potentially try it out if you're looking at migrating Kafka. We did try it out in lower environments with multiple iterations. We had some success, we had some challenges, but we never went with either of the path. The downtime of DigitalOcean actually forced us to migrate to a hard move. And I think that's how we ended up porting Kafka. Go ahead, Sri. Yeah, I think this is where we are now, right? We're not saying we are done with our digital transformation, but we've moved. We moved a lot. We are at a very different state than where we were. As you look at it, since from the beginning, where a developer makes the changes in their code bases, the CI/CD pipeline, which is GoCD, kicks in, and with the help of automation like health charts and Dockerizing, we deployed into Kubernetes. Now all of our workload, except for a very small 1 or 2% footprint, 98% of our workload is on Kubernetes, which means repeatable deployments, consistent deployments. There's a consistent way how you manage your systems. While deploying, the configuration management we touched upon using Console and Vault, so that the centralized configuration management gives both ability to the developers as well as the business to manage business toggles, for developers to manage technology configuration changes. And we had evolved our monitoring and observability stack in general, both for logging as well as for monitoring. And we've evolved over time, like we added high availability for monitoring, like she mentioned about Thanos. We moved from vanilla Elk stack to having back pressure and Kafka and Logstash based solution out there. So this is where we are. This is again not the 100% picture of where we are, but should give you a sense of from manually managing to 100 plus missions, how we went into completely automated solution. Which helped a lot of new developers just come in and just directly start focusing on the business problem and not spend so much time on learning how things are done here. So you need to probably learn only if you have to make changes here, but if you're focusing on a business problem, all you need to understand is the microservices that you're working on is deployed. Everything happens seamlessly behind the scenes in a completely automated fashion. We've reached an automation to an extent where today environments are click of a button. Previously we had two environments like dev and production, which used to cost us a lot, right? And with hundreds of microservices, you could imagine the cost each of the environment would cost. To spin up a new environment, it was not even a simple thing to do. Every time, different groups within technology comes and ask, hey, we need a dedicated environment either to do performance testing or either to do UAT or whatever. It used to be a nightmare, and we never could, actually do it with our old system. With the level of automation we had today, every weekend, we by default, there are automation rules which turns off lower environments if there is no work happening. Every night after 11 o'clock, some of the lower environments just turns off automatically, and morning 5 o'clock it spins up, right? All it takes is 20 to 30 minutes for the whole environment of hundreds of microservices to come up. I think that's the beauty of automation. Which is why we highly, highly recommend start with automation, even if you're starting the first service. I think the cost of, you could have avoided all of this transformation journey that we've spoken about if you start thinking about that automation from day one. And it's a lot more easy. You don't have to think about, downtimes, outages, seamless migration and all of it. But I'm pretty sure a lot of you don't have that luxury, which is why this story offers to you. If you are at the stage where you lost that opportunity and you want to get here with complete automated infrastructure, how do you get? What are some of the lessons that you need to keep in mind? How do you set expectations? Why some of the preparation important? How do you execute? What are the checks and balances you need to have post migration so that you could validate and all of it? And how would it benefit? Environment at a click of a button is very, very few organizations reach that kind of a maturity. And today, literally, even if one developer is working over the weekend, they don't even have to reach out to DevOps infrastructure. They go to a CI/CD tool, say that, no, I need a new environment. It spins up the new environment with such a complex dependency graph and all of it. They do the work and they turn it off, right? That's the level of sophistication that we have got. And like I said, our transformation is not ended here. Now we are exploring how do we get into preemptible nodes so that we could save costs. Given we have auto scaling and auto healing also, which you get by default with Kubernetes, but the default one, as always, is not good enough. So we are building some more sophistication over there so that, how do we leverage preemptible nodes so that we could even bring down our costs and so on. Next slide. Yep, that's all we had. I think that's our tech channel, Rapido Labs at Medium. We keep writing about all our learnings. I think there are quite a few blogs out there which covers the same topics that probably we spoke about in the last hour or so. Go check it out if you want to get in detail. But also reach us out to the next slide. Sri reaches out to some of our email handles or Twitter and LinkedIn handles which were presented early on. We are happy to answer if we could help in any other way. So that's all we had. Thanks a lot for this opportunity. Divyo, over to you.
Yeah. So hi everyone. So first of all, thanks a lot to all the attendees who were there in the Saturday evening with us. And next up, the speakers. You were awesome throughout the session. And yeah, it helped me a lot to see the architecture. And yeah, so being a developer, it's nice to see this great architecture and having to see it working. It's a good thing. So yeah, I think about the Q&A, right? So I think you have answered most of the questions in the chat. So yeah, so this time we'll not be waiting more for questions, and we'll be concluding the session here. So thanks a lot, Sri Ranjan and Sivatsa for being here.
Thanks, guys.
Thank you.
Bye-bye.
Yeah, bye-bye.